Everyone, stand. Mr. Digma, kindly lead our prayer. Thank you. Good morning, class. Again, good morning, class. But before you take your seat, kindly pick a piece of paper and arrange your chair properly. Okay, thank you. How are you today, class? I'm happy that you are okay. But before we proceed to our discussion, let me present here our classroom rules. First, listen actively. Interact respectfully. Mind your focus. Involve yourself in learning and take responsibility. But before we proceed to our formal discussion, let's have first our activity entitled Balloon Dash with a Twist. For our mechanics in our activity entitled Balloon Dash with a Twist. In a balloon dash, 3 groups with 6 members and each will race holding balloons between them without using their hands. The teams race together towards the finish line while keeping all balloons in a place. And if a balloon drops or bursts, they must stop, fix it, and continue from where they left off. At the finish line, the front member of each team will be given equations to solve. The team that crosses the finish line with first and answer correctly wins, and the teams who won will receive the prize. Since you understand our mechanics, we can start our activity, and you can go to your respective groups. Okay, thank you for your active participation. This group wins. So your prize you will be claimed after our class.
Before we dive into the specific topic, let's take a quick look at what we aim to achieve today. By the end of the lesson, you will be able to, everyone please read, Improper Integral with Infinite Upper Limit. Now, let's start with the basics. What is proper integral? Alright, a proper integral is defined as the integral from a to b of f of x dx, where both a and b are finite real numbers, and the function f of x is continuous on the closed interval a and b. Essentially, it represents the sine area curve y is equal to f of x, and the x-axis is equal to x is equal to a, 2x is equal to b. Today, we'll focus on improper integrals with an infinite upper limit. To evaluate this, we use the following formula. The integral from a to infinity of f of x dx is equal to the limit as t approaches infinity of the integral from a to t of f of x dx.
Now, it is a crucial concept when dealing with improper integral is whether they convergence or divergence. If the limit exists and is equal to finite real number L, we say that the improper integral is convergent to L. And if the limit does not exist, or either because it is infinite or because it is obsolete, we say that the improper integral diverges. Miss Albor will show you one of the examples of the convergent integral. Miss Irene?
Now, let's move on for our first example. Evaluate integral 1 up to infinity of 1 over x squared dx. The first is rewrite as a limit is equal to the limit as b approaches to infinity of integral 1 up to b of 1 over x squared dx. Next is find the antiderivatives of 1 over x squared is equal to the limit as b approaches infinity, then the antiderivatives of 1 over x squared is equal to negative 1 over x. Now, evaluate from 1 to b is equal to the limit as b approaches infinity, negative 1 over b minus negative 1. Take the limit as b to infinity is equal to the limit as b approaches infinity, 1 minus 1 over b. Is equal to the 1 minus 0 is equal to 1. So, since bakit nga ba naging 0 yung 1 over b? Kasi, pag denominator natin ay b, lumalaki yung value niya pero lumiliit sa fraction. So, kaya naging 0 ang ating 1 over b. So, 1 minus 0 is equals to 1. It means that is convergent.
So let's proceed to the example of divergent integral. Our first example is evaluate integral of 1 up to infinity 1 over x dx. So for our example, our first process is we are going to rewrite the equation into limit. So it is equal to limit b up to a infinity integral of 1 up to b 1 over x dx. And our next process is we are going to find the antiderivative. So it is equal to limit b up to infinity ln x up to 1 up to b. So our next is we are going to evaluate 1 up to b, 1 from to b. So it is equal to limit b up to infinity ln b minus ln 1. And so we are going to, so yung ating ln 1 is magiging 0 na siya. And it will become limit b approaches to infinity ln b. And habang yung b is approaches to 8, is lumalaki ito in an infinite process. And kaya mabagal din yung ano niya, yung paglaki is it is unlimited pa rin siya. So our final answer for this equation is limit b approaches to infinity ln b minus ln 1 is equal to infinity. So it is a divergent. Now, let's proceed to our third one. So evaluate each of the following integrals or show that it is divergent. Our first equation is integral of 1 up to infinity dx over square root of pi x. And our second equation is integral of 1 up to infinity x over 1 plus x squared quantity of squared dx.
Mamaya mo i-video. First is rewrite the integral. is equal to the limit b approaches to infinity, integral of 1 up to b times pi x raised to negative 1/2 dx is equal to the limit b approaches to infinity, integral of 1 up to b. Right. So we have the 2 over pi times pi r raised to 1/2 b 1 up to b. Now evaluate the definite integral is equal to the limit b approaches to infinity 2 over pi times b pi raised to 1/2 minus pi raised to 1/2. Now, substitute the upper and lower limits of integration 1 and b into the antiderivative and subtract the result at the lower limit from the result at the upper limit. So, we have infinity. As b approaches infinity, square root of pi b also approaches infinity, therefore limit is infinity. Second is evaluate the integral of 1 up to infinity of x over 1 plus x squared raised to 2 dx. So we have limit b approaches to infinity, integral of b 1 up to b of x times 1 plus x squared raised to negative 2 dx is equal to the limit b approaches to infinity times negative 1/2 times 1 plus x squared raised to negative 1 up to b is equal to the limit of as b approaches to infinity times negative 1/2 times 1 plus b squared raised to negative 1 plus 1/2 times 1/2 is equal to 1/3.
Okay, we done to our discussion. We prepared 3 questions to generalize our topic. So our first question is why it is important to know whether an improper integral is convergence or divergence. Second question, how can improper integrals be applied in probability, physics, or engineering? So let's proceed to our last question. How can you tell an integral with an infinite upper limit will give a finite value or go to infinity? This is your activity to be submitted in our next meeting. So, evaluate the improper integral. The first equation is integral of 2 up to infinity 1 over x minus 1 squared dx. Second, integral of 0 up to infinity x raised to negative x squared dx. And the last equation is integral of 1 up to infinity ln x over x dx. I hope that you enjoy and understand our topic for today.